Hey, Algebra 2. This is Unit 3, Lesson 2. And we did square roots today and cube roots today. And yeah, so part of, if we jump back to what the lesson was, we started off with this little shape. And what was the whole point of this? The whole point was to look at this and not just to find the area, but to introduce the idea that we could use the Pythagorean theorem and remember that when you square the sides, and then take the square root of them, we could find this missing side. That idea of finding the square root of a number, and that it's the opposite of squaring a number, that was one of the key concepts. And then we worked with this little set of shapes and looked at their areas. And here's the thing. If you wanted to find the side length for any square, well, square roots, the side length is the root of that square. The root of that square's area. It's literally part of the name. So, so if it had an area of 1, its root would be a 1 by 1. If its area was 2, its side length would be the root of 2, which is about 1.414. And so we also learned how we could estimate roots, like this one. It has an area of 8, so its side length would be the root of 8. And we said, well, hey, the root of 8 is just a little less than the square root of 9, and the square root of 9 would be 3. So this is going to be a number like a 2.9 or something like that. It's going to be a decimal that's a little less than 3, because again, its area is a little less than 9, which would be for a 3 by 3 square. So yeah, then we looked at this and said, hey, what if you had a square whose area was 9? Well, then its root, its side length, would be a 3 by 3. If you had a 4 by 4 side length, then its area would be just squaring that. 4 times 4 is 16. And for this one, you're allowed to literally just write, if the area is 23, then the side length must just be the root of 23. Now we can estimate that, and the root of 25 would be a little bigger than this. And so, the number that we'd have here would be something not like 5, but a little less than 5, like a 5.8 or a 5.9. Again, with this, you would do 6.4 times 6.4 to get the area. You would square that side length, and then you would take the root of the area to get this side length. Then you can just write root 89. Okay, and then we looked at estimating cube roots, and we looked at estimating those by creating a whole bunch of benchmark perfect cubes on the board. Remember that 1 is a perfect cube because 1 times 1 times 1 is 1. 8 is a perfect cube because 2 times 2 times 2, 3 times would give you 8. 5 is not a perfect cube. 10 is not a perfect cube. 50 is not a perfect cube. Here's the thing, though. 1,000 is a perfect cube because that's 10 to the third power. And so if we took the cube root of 1,000, we would get 10. And the cube root of something like 1,200 is going to be between 1,000 and 11 times 11, which would be 1,300. So the answer for the cube root of 1,200 would be somewhere between 10 and 11. And then we also saw these other ones. Okay, so let's jump into here. Oh, there's the answers for the homework. Let's jump into the practice. I asked you to do numbers 1 through 5. And so this first one should be a little review. Rewrite the following expression as a number with no exponents. So that means we're looking at this and saying, how do we solve this? Well, okay, yes, we could do the powers and we could subtract the powers. We could take this whole fraction, and since we got negative powers on the top and the bottom, we could flip it. And I kind of want to do that first. If you want to see the subtraction of powers, that's right here. But I kind of want to flip it and put 7 to the 5th, positive 5th up top and 7 to the 3rd on the bottom. And if I did that with a 5th power up top and a 3rd on the bottom, 5 minus 3, we would have 2 extra 7s on top. 7 squared, which is 49. That's the way I personally like to do it, is that I like to take these negatives and make them positive first. Okay, number 2, again, another little bit of review. This is just looking at these expressions and saying what would the power have to be in order to make this a 12? Well, 4 times a 3 would make 12. And here we add these powers together. But they're different bases, so we can't add them together. So this is one of those ones that you have 5 factors of 3 times 5 factors of 7, and that would result in 5 sets of 3 times 7, which is 21. 21 would be that number, because when you multiply all those 3's and all those 7's together, you get 5 21s. And this one is one where you add the powers of 0 plus what number would be 4? Well, this number would have to be a 4. Okay. Now, new stuff, stuff that went right with today's lesson. This is our learning target especially when we get to like number 4. An area of a square is 9 centimeters. How long is its sides? Well, again, it's a square. So what times what makes 9? That would be 3. Okay, we move on. That's the easy one. Number 4 is one where this is just like what we did in class. And you say, okay, well, what's the area? If the side length, so look how these are flip-flopped. If the side length is 5, the area is going to be 25. If the area is 49, well, the side length is going to be the root of 49, which would be 7. If the side length is root 63, that means the area must have been 63. And if the side length was root 125, the area must be 125. And then if the area is 98, then the side length must be the root of 98. And again, you could also estimate these roots here. Okay. And number 5, the last one, says find 2 whole numbers that are the closest to the root of 42. And that's where you look at, okay, 42 is a square. What other perfect squares are a little bigger than 42, like 49, which would be 7 times 7, and a little less than it, which would be 36, because it's 6 times 6. So the 2 whole numbers would be the 6 and the 7 that are closest to the actual root of that answer. Okay, folks. So yeah, today was a class where you're getting comfortable with square roots, and there was no practice on the homework for cube roots, but remember, we also did some cube root practice in class. All right, hope that's making sense. Take care. Bye.